I'm Kevin Williams, and I'm on a mission to explain why science matters to motorcyclists via my 60-second science short video series. Kinetic energy is defined as the energy acquired by an object due to its motion, and last time out I explained that when we're riding a moving motorcycle, both the bike and our own body possess this kinetic energy. And I did the maths to prove that the motorcycle moving at just 30 miles per hour possesses more than 40 times the amount of kinetic energy possessed by a 9mm handgun bullet. So let's move on to the second part of our understanding of kinetic energy. How does the value of our kinetic energy change as we accelerate and, rather more importantly, decelerate again? If we want to accelerate an object, such as us sitting on our motorcycle, then we must apply a force. That's what we have an engine for. The engine burns fuel, the pistons go up and down, the crank rotates, turning the chain or shaft, and makes the back wheel rotate, pushing the bikes forward. We call this change of speed acceleration. In essence, the energy contained in the fuel has been converted to the energy of movement of bike and rider, kinetic energy. The same would apply on an electric motorcycle. The energy contained in the battery is converted to motion. The amount of kinetic energy held by the moving motorcycle depends on its mass and the speed we've achieved. We have to use more energy to accelerate a heavy bike to the same speed. That's why a 125 uses less fuel than a 1250 BMW around town. And leaving aside the impact of wind resistance, we also have to use more energy to accelerate to a higher speed. Once moving at a new constant speed, the bike's kinetic energy is directly proportional to the square of the velocity. The same applies to the rider, incidentally, since we're attached to the bike. Acceleration can also be negative. We usually call it deceleration. If we simply roll off the throttle, wind resistance, rolling resistance, and the internal friction of the engine all combine to slow us down. If we need to slow down more rapidly, the bike's kinetic energy is converted to heat due to friction between the brake pads and the brake discs. Electric motorcycles may use regenerative braking and recapture some of the energy by recharging the battery. Here's the important bit. Our final stopping distance is directly related to the kinetic energy now stored in the bike. Since kinetic energy is proportional to the square of the speed, stopping distances also increase with the square of the speed. If the speed of our motorcycle is doubled, our stopping distance will be 4 times greater, assuming constant braking force. Even modest increases in speed result in significant increases in kinetic energy and thus stopping distance. Next time out, how does speed affect what happens if we crash?